Hello everybody, my name is Tatiana and welcome to my demonstration video series on OTF Studio thin film software. Very modern, fast and powerful software for designing, characterization, reverse engineering and monitoring of multi-layer optical coatings. In this video, I will show you how to design a bandpass optical element with a dynamically adjustable high transmittance range. Optical element which I would like to design should exhibit a high transmittance range, dynamic around approximately 550, and two low transmittance ranges. One is from 350 and the upper boundary will be dynamic, and another low transmittance range is from 600 to 850. And I will design two filters, Longpass filter for the front side of the substrate and Shortpass filter for the back side of the substrate. And the transmittance of this entire optical element will give the desired performance. So it will be dynamic bandpass filter. Let's start. I open an OTF Studio project configured for this design problem. I have two materials, dispersive, titanium dioxide, silicon dioxide. They are loaded with names. Substrate, suprasil is also loaded. And the first target will be long pass filter. So with low transmittance, with zero transmittance from 350 to 500, and high transmittance from 500 to 600 nanometer. Here I have environment panel, which shows me all loaded information, target, materials, substrate. The transmittance plot in the middle, this black curve shows transmittance of the uncoated substrate without backside. Of course, it's possible to take any starting design, maybe one layer design, but for this design problem, I will take starting design, which is slightly chirped mirror. I will show you this mirror in the profile. So I will move this profile to save the space. It's slightly chirp mirror. So quarter wave thicknesses are slightly modulated, and this starting design provides already low transmittance, or better to say high reflectance, in the short wavelength range. I focus now on the design builder panel, which controls all design algorithms and settings, and switch to gradual evolution. And my setting is that the number of layers should be less than 40 layers, and run the algorithm. And very fast, it will be many solutions in the history. I can simply extract some of them, 40 layers, 39 layers, 38 layers. I will take these 39 layers without thin layers, without thick layers. Thinnest layer is 21 nanometer. And save this design solution under the name Longpass filter. Save, commit, and this is in my database. To design the backside coating, I loaded the short pass filter target, so another target with high transmittance between 500 and 600, and zero transmittance between 600 and 850. I can take again any starting design, including one layer, but I will take start this starting design, a slightly modulated mirror or quarter wave mirror, and this is shown here. And this mirror will provide low transmittance in the range 600-850. So this is my starting design, and I can start design process. We focus on design builder panel, the same design method, gradual evolution, and start gradual evolution, start designing, and very fast. For example, 40-layer solution or 38-layer solution or 37-layer solution, 35-layer solution. All solutions are very good without thin layers. In this design, for example, the thinnest layer is a 52 nanometer. I will take this design and save it under the name short wave pass filter. Short pass filter. And now I have two coatings for both sides of the substrate. And now I loaded a bandpass filter target, so 3 ranges, 2 low transmittance ranges and 1 high transmittance range. And I would like to combine these two filters, long pass and short pass, in one optical element. I focus on my environment panel, load long wave pass filter as front side design, activate the backside, and load the backside design as short pass filter. And we can see this is a combination, so this is transmittance of the substrate coated from its both sides. To demonstrate the dynamically adjustable high transmittance range, I focus again on the design builder and select variator, which is interactive analysis tool. Here it's possible to vary individual layer thicknesses, offsets in layer materials or substrate or incident medium. But in this, in my case, I will concentrate on the control wavelengths. So I open control wavelengths and correction factors panel. And here my control wavelengths, this is in the center of my spectral range, 550. And I, using sliders, I increase the wavelengths and monitor what is going on with transmittance. Transmittance range, high transmittance range, is getting more and more narrow. At the same time, we can see that performance is excellent. So it's getting more and more narrow. So this is adjustable. The structure of design is changing, but not significantly. We can keep up our good structure. And also I can go to the opposite direction and decrease the control wavelengths again. Now I would like to have a look at transmittance and in optical density scale. I can open settings, intensity units, and change instead of percentage, optical density. So we can see that transmittance in low transmittance range is more than 2 in the entire spectral range. And also here we can increase or decrease the control wavelengths and observe what happens with transmittance in optical density scale. Generally, this is an illustration, a demonstration of such filters. Both filters from front and back sides are 37, 38 layers without thin layers. and they provide good performance for the entire spectral range. Thank you for watching, and if you have questions, please contact me, and see you in the next video. Bye!